Here's a sneaky one. So you can see the answer, there's no critical points. Why is D not a critical point? Well, while it's true I could fit a horizontal tangent line at D, I could also put a whole bunch of different shapes, tangent lines at D, which would cut the function, just touch the function at D, but they're not unique in any way. And this kink, we call this a kink. There's a kink in the function. This function, if we call it f of x is not differentiable. So it has no derivative at point D. So it's kind of cheating. And since it's not a critical point, and this function is not differentiable, our rules before don't apply. So f prime, so only functions that are differentiable can we say that f prime of x is equal to 0 in order for x to be an extreme value. So D is an extreme value. It's a min, but it is not differentiable. So our rule does not apply. So our rule, we're studying calculus here, so we like to have functions that are differentiable because that's what calculus is about. That's what differential calculus is about anyway. And if we have a function that is not differentiable, represented by this kink, no unique, there's no unique tangent line at that point. And so our rule about critical points being a necessary condition for an extreme value doesn't apply in this special case. We've got a medical example here. We're looking at giving a drug to a patient, and we've got a function here that tells us the concentration of that drug or chemical in the patient's bloodstream after the dose has been injected. Now, can we find the point at which concentration is highest after injection? So let's assume that t is equal to minutes. And we know that if we're going to try to find, well, maybe there's a few things we can do. We can see here that if t, or at least that the domain of this thing has to be t greater than 0, and it can go all the way up to infinity. So we'll have a very broad domain, but certainly this value has to be greater than 0. There's no such thing as negative time. Now, we're not really interested in what happens at 0. So let's see if we can find an interior interior extreme value, and what we really want is a max. So if it's an interior extreme value, it must be the case that C prime t is going to be equal to 0. So let's find C prime t. We have to use the quotient rule. So we get 1 times the denominator minus the numerator multiplied by the derivative of the denominator, and all that divided by the denominator squared. And if I simplify this a little bit, we get t squared plus 4 minus 2t squared over the very same denominator. And if we simplify this some more, the numerator becomes 4 minus t squared. Or 2 minus t, 2 plus t divided by t squared plus 4 squared. Now remember that this is equal to C prime t. So this sort of ugly thing here, this is our slope. And you can see how the slope is changing over time. Now the question becomes, at what value of t is C prime t equal to 0? And the answer to that is what? Maybe I should phrase this as a question. And you're looking at it and you're using your brain. And what value of t is going to set C prime t equal to 0? Remember that t has to be greater than 0, so it can't be less than 0. And if we have t minus 2, if that were equal to 0, in other words, if t is equal to 2, then C prime 2 is going to be equal to 0. But we can say that C prime 2 is a critical point, and C prime 2 could be an extreme value. Now later I'm going to show you some tests that we can use to figure out whether this is an extreme value, well, maybe not so much an extreme value, but whether this is positive or negative, and whether it's at least a local max or a min. We'll do that later. For now, let's just graph our original function, this thing here, and see what that looks like. And when we do that, we can see our critical point here, right? And that looks like our critical point occurred when t was equal to 2, so 2 minutes after injection. And then we've got C of 2 up here. And after 2 minutes, the drug starts to rather quickly wear off. At least, or I shouldn't say wear off, it starts to leave the bloodstream. And so looking at the graph, and based on our domain, this thing just keeps going. Eventually it's going to get very close to, well, it's going to keep getting closer and closer to 0. Looking at the graph and based on our domain, we can say that this is an extreme value and it's a maximum. It's extreme value maximum.